So that's another shape that I could have with 4 total bond groups. Again, 4 total bond groups is based on 109.5. That angle shouldn't be too bad. Water, okay, that one wasn't too bad to draw. I end up with 4 extras, so this time I can actually use 2 lone pairs because hydrogen only wants 2 each. So I get 2 bond pairs, and I get 2 lone pairs. Again, this thing is based off of 4 total groups. So I think of my shape with 4 total groups again. And now all I'm going to do is I'm going to take 2 away. I'm going to take this guy away. I'm going to take this guy away. And I'm left with a shape that looks like that. And that should look pretty familiar to you. Looks something like that. I would have a lone pair here, a lone pair here. So you make out my 4 total groups. That shape, again, is bent. We have 2 different bent shapes. They're both called bent. There's a big difference, though, and that difference is in the bond angle. This guy, the other one was based off 3 total groups. This guy is based off 4 total groups, so right away 4 total groups. I go 109.5. And now this is probably my favorite bond angle, just because only in chemistry are you allowed to do this. But I have 2 lone pairs. Each lone pair makes it less, and I have 2 of them, so I go less than 109.5. It was less than the one that was less than 109.5, and that one just sort of cracks me up a little bit, but that's really the way you would write it. 4 total groups, again, 2 bond pairs, 2 lone pairs, we're going sp3. And we know water is polar, and the reason it's polar is because of this shape, because of this bent shape. So that takes care of my 4 total groups. I've done my 2s, I've done my 3s, I've done my 4s, and we're getting there. PF5. Okie doke. This is another nice one. Thought this is the first time, and as soon as you see F5, you go, oh, I know what's coming here. This thing's expanded, and I make sure I go to P, and I make sure that P can go expanded, and it is in the 3rd energy level. So I'm okay, because I can now use d orbitals and be able to go expanded. So I get this guy here where phosphorus is bonded to 10 things. And now I'm going to explain sort of the reasoning for you here. The shape that makes has a couple of different bond angles now, and it looks like that. 5 bond pairs, no lone pairs, looks like that. And I've got a couple of things going here. I've got these 3 in the middle that form a triangle. And then I've got sort of 2 different tops to that triangle. So what you get is I get 2 triangular pyramids, and that thing is called trigonal bipyramidal. I don't, and you sort of have to picture that shape. It's a flat triangle in the middle, and then I have one on the top and one on the bottom. But you have to be able to see that shape in order to do the next two of these. I'm not going to memorize bond angles. Let me see if I can just quickly get rid of that. And I'm just going to look for them. Again, this thing's trigonal bipyramidal. Between the top and the bottom and all three in the triangle, I have 90s. There's a 90. I have that triangle in the middle. Remember, I could sort of sketch a circle around that triangle, and we said the bond angles there were 120. And then I also have the full-blown thing, which is 180. The top and the bottom are 180 degrees. So when we're talking bond angle, you have to report out all three. Hybridization-wise, I've got 5 now. So I've got one S, that's all of my S's. I've got 3 P's, that's all of my P's, and this makes sense because it has to be. We've talked about what you need in order to be expanded. This is why, because now I need a 5th orbital, and that 5th orbital is a D, and I only need 1 D to get to 5. No lone pairs. The way this works out is that it's nonpolar. So that's my 5 shape, and lock that thing in. Flat triangle, one on the top, one on the bottom. We're going to use it again right here. Okay? SPR4, see you in a minute. Okay, you have a shape now where you've got a lone pair, 4 bond pairs between S and BR, but I also have a lone pair. Again, this thing's going to be based off of 5 total groups. Oop, I don't want to show you that yet. So again, here's the rule. I've got the ones in the middle, those are the triangle. I've got one going up, one going down. Triangle, one going up, one going down. On your rule is that you attack the triangle. So I still have my one going up. I still have my one going down. But I'm attacking the triangle. And I'm going to take away the one that goes this way, leaving me this guy and this guy, and then it sort of rotated it a little bit for you. And they call that shape, this is my favorite shape, and you look at that and it looks just like it when it's drawn this way. That shape is called seesaw. Looks like a seesaw. Okay, bond angle wise, I think I think I'm pretty much in the same place I was before. These guys are from the flat part to the top. That's a 90-degree angle. No problem. I have this 120 here. If you want to really be technical, it's probably less than 120 now with the lone pair. You don't really need to worry about that necessarily. I also have the top and the bottom, both ends of the seesaw. That's 180. Nothing changes hybridization-wise. 4 and 1 is 5 total. 1S, 3 Ps, 1 D. The difference now is I have that lone pair, so I am polar. So that's the first thing. But the rule is, and this is really the rule you have to memorize, with 5 groups, you attack the triangle. And we're going to continue to attack the triangle here. The BRF3 Okay, this one's interesting. 3 bond pairs and 2 lone pairs now, because I had 4 left over. Expanded again. Bromine has 2, 4, 6, 8, 10. And again, I'm going to continue to attack the triangle. So that's where it ends up. Again, I want to show you where that came from. I get this guy in the middle, and I have the triangle. I'm attacking the triangle, so I'm leaving my top and my bottom alone. And what I'm going to do is I'm going to attack this sides of the triangle. That's the one lone pair, that's the other lone pair, and it leaves me with that guy, which I will then flip a little bit to that, and that thing, again, it looks like it once you form it, is called T-shaped. Makes a T. Bond angle-wise, I've got 90s. I've gotten rid of all but one thing in my triangle now. I don't have my 120 anymore, and I still have my 180. 3 and 2 is 5. Nothing changes hybridization-wise because lone pairs count. sp3d, oops. 2 lone pairs, it is, and definitely I have a pole here that I'm not canceling out. That's polar. So I'm attacking my triangle. 5, you attack the triangle, attack 1, attack 2. We'll look at one more with that. And this one's interesting in a lot of ways. First of all, this should be weird. You've got xenon, and it's bonding. It's a noble gas, and it's bonding, and that happens sometimes. The other thing that's strange is that it's 3 lone pairs giving me 2 bond pairs, and 3 lone pairs, that's a 5 total group. And again, I'm going to attack the triangle, and this time I attack the triangle. I still have my 1 up, my 1 down. I have a lone pair here. I have a lone pair here. I have a lone pair here. I've gotten rid of the whole triangle. And the effect of that is that I'm left with just a line. This one is a different way to get to linear. 180 degrees. The difference is 2 and 3 is based off of 5 groups. 1s, 3p's is 4, 1b is 5. Anytime it's a line, though, and I know this one has lone pairs, but if I know the shape and I know it's linear, I have a pole here, I have a pole here, those exactly balance each other out, and that guy is not polar. So that's all of my 5 shapes. It goes from trigonal pyramid, I attack the triangle to get, bipyramid, I attack the triangle, I get a seesaw, I attack it again, I get a T, I attack it again, and I get a line. 3 more to go, and they're based off of 6 groups. Hang in there. That works out sort of nice. Anytime you see a multiple of 6, I would say you're in pretty good shape. This one's definitely expanded again. I knew that ahead of time because it was F6, which means I need to have 12 things around sulfur. Sulfur's okay. It's an energy level 3, so I'm good there. 6 groups are similar to sort of to 5. The difference is now I still have one going up. I still have one going down. Now I think, okay, I've got 4 left over. And if I have 4 left over, that middle is going to be a square. And I'm not going to try and draw this on here, really. I guess I can try. What you get is you get this thing that has 8 faces. There's 8 triangular faces to that. I could probably try and draw it better again. But that thing, and this one you might again memorize, it's called octahedral. Bond angle-wise, I've got the ones between the tops and the base. Those are always 90 degrees. Now in the middle, I've got this square. Squares also are 90 degrees, so I have a lot of 90-degree angles, but no new bond angle. And then tops and bottoms and outsides are 180s. I'm looking at 6 plus 0, that's 6 total groups, so I need 1 S. I need 3 P's, and I have 2 more that I need, so now I'm pulling 2 D's, which is fine because I've got 5 of them. No lone pairs, non-polar. Okay, now here's where we're headed, and you know where we're headed. We're going to start to take things away. The rule for 6 is not the same as 5. 5, you attack the triangle. 6, you attack the top and the bottom. So picture that here as we go. We're going to take our square and a top and a bottom, and we're going to attack the top and the bottom instead. Okay, I'm working 5 bond pairs and 1 lone pair, and again we said we're going to attack the top or the bottom, so I'm going to take away the bottom. I'm going to turn that into a lone pair, and I'm left with my square with a top, so that thing is called square pyramidal. I made a square pyramid. I'm attacking the top. In this case, I attack the bottom. I look at bond angles. I wouldn't memorize these. You can see them. There's a 90. There's a lot of 90s still. And there's that 180 across the square. It's still 5 plus 1 is 6 groups. 1, 4, 6. The difference now is I've got this pull this direction with a lone pair, and it's polar. And before we move on here, take a moment. Whew, last one coming up. Okie doke. Now I've got 4 bond pairs and 2 lone pairs. This thing works out to 6 total groups. And again, I'm going to attack the top and the bottom. So right away, I should know I'm going to attack the top, get rid of that. I'm going to attack the bottom, get rid of that. And you should, before we even go there, you should see that all I'm going to be left with is the square. And it's a flat square. Flat means planar. So this is square planar. Every angle in that square is 90 degrees. In theory, I still have my 180s. 4 and 2, it's based off 6 groups, SP3, D2. And again, this one's a little interesting in that it's a flat square with an equal pull in every direction. So this one's sort of unique in the fact that it is nonpolar. Whew. Here's what you have to be able to do. You've got to be able to draw correctly. Then you have to be able to count groups correctly. Remember, if it is a multiple bond, it's still only one group, but lone pairs also count as groups. And then once you count groups, spread them out and see where they're going to fall. We'll do lots of practice on this. Thanks for hanging in there. See ya.